Do you like robots? Because I sure do. So in today's video, I'm going to be using artificial intelligence and face recognition to determine my emotions through my webcam in real time. Also, if you enjoyed this video, make sure to let me know down below so that I can create a part 2 to this video where I use face recognition in order to determine who is in a picture and display their name next to their face. Are you tired of going to watch your favorite show with one of your friends, but they don't know who any of the characters are, so they completely ruin it by asking you, "Who's that? Who's that? Oh, who are they?" the entire time? Well, no longer will that be a problem, because in today's video, we're going to look at creating a facial recognition app where you can upload any photo you want and it'll tell you exactly who's in that photo. Let's get started now. Let's take a quick look at the project we're going to build. All we need to do is select an image here, and we just take any image we want, and then it's going to find all the faces in that image and give us the name of all the people for the faces that it recognizes. To get started doing this, I already have quite a few files in our project. As you can see, I have a folder here with labeled images. This is just facial images of all the different characters that we're going to be able to put labels to their names. So we have Black Widow, Captain America, and so on. And these are just face shots of all these different people. You can find these yourself if you want, or you can find them on the GitHub that I have linked in the description below. And then also, besides these labeled images, I have the various different models that we're going to need. This is what our AI network is going to use to determine people's faces as well as recognize their faces from these images. And these again are going to be in my GitHub repo linked below, so you don't have to go worry about finding them yourself. Then lastly, we just have a couple test images here. These are just the various images that we're going to use that have these people's faces in them. And again, they're in the repo linked below. Lastly, I have the Face API minimized library here, which we're going to be using to do the face recognition inside of this project. And all we need to do is add a new file here, which is going to be our index.html. This is going to be for rendering our page, and we're also going to have a script.js, which is going to be all of our custom code that we're writing for recognizing these faces. Now to get started, let's set up our index.html. We can just hit !enter using emmet in VS Code, and that'll automatically generate this template for us. And inside of here, we can just say face recognition, because that's what we're going to be building. And inside the body, it's going to be super straightforward. We just need a single input, which is going to be a type of file, and we just want to give it an ID so we can reference this in our JavaScript. We're just going to say image upload. And then I'm going to use a few styles here inside of the body or inside of the head tag, because I just want to be able to style our page so that everything is centered. And to do that, we'll just select the body. We're going to get rid of all the margin, all the padding. We want to make the width here equal to 100 view widths, so it's going to take up the entire width. And we want to make the height equal to 100 view height, which again will make it take up the entire height. We want to use display flex combined with justify content center and align items center. And this is just going to center our content horizontally and vertically. Then lastly, we're just going to use flex direction, and we're going to make this column. And this way our different elements stack on top of each other. As you can see, our selector and our image are stacked on top of each other instead of side by side. Now lastly, we're going to be using a canvas element to draw these different rectangles around the images of our characters. So we need to absolutely position this so it goes right over top of our different image. So we can just make this here a position of absolute. Make sure I spell that correctly. There we go. And now we can jump over into the JavaScript, which is going to be where the really interesting parts of this project come into play. And if you haven't already seen my facial detection video, which uses the same exact library, I highly recommend you check that out now, because certain parts of what we're doing here are what we covered in that first video, and I don't want to cover them as in depth in this video, so make sure you check that out first if you haven't already. Now moving on, what we want to do is first get our image element. So we can get our image upload, which is going to be equal to document.getElement by ID. And we just want to get the ID here of image upload, which is the ID that we gave our element. And this is so that we can get the files that we're uploading. Next, we want to load the different models that we're going to be using. And the various models that we're going to be using, we're going to use face API.nets. And then in here we put the library name that we're using. So we're going to use face recognition because we want to be able to recognize the faces. So face recognition net. And we want to just load this. So load from URI. And we're loading this
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Alvin Aprianto dari kelas IKA 1D absen 2. Di video kali ini saya akan mendemonstrasikan hasil kerja saya yang berupa program Smart Absensi yang saya namakan Face Attendance Smart Absensi. Dalam program ini saya menggunakan beberapa library, diantaranya OpenCV, NumPy, Pillow, dan beberapa library lainnya. Di sini saya ada file eksekusinya atau programnya, kemudian folder data wajah untuk menyimpan data dari wajah kita, lalu ada folder latih wajah untuk menyimpan hasil dari training wajah kita. Kemudian di sini juga ada file Excel untuk menyimpan data dari absensi kita, dan di sini ada algoritma hard cascade yang digunakan dalam program ini. Baik, kita langsung saja eksekusi programnya. Di sini kita bisa lihat sudah muncul contohnya mengambil data. Di sini sudah masuk. Sudah masuk. Di sini sudah masuk pada folder data wajah. Kita cek pada sudah tertulis rekam data. Di sini sudah tertulis rekam data sudah selesai. Kita cek pada folder data wajah. Di sini sudah masuk. Kemudian kita klik tombol training untuk melatih komputer supaya mengenali wajah kita, di mana membutuhkan waktu yang cukup lama. Ya sudah, kita bisa cek di folder latih wajah. Sudah masuk ya. Setelah itu kita bisa melakukan absensi dengan mengklik tombol Automatic Attendance. Di sini sudah ada saya sendiri dengan nama saya dan tingkat akurasi dari wajah saya. Kemudian kita exit dengan menekan tombol key. Setelah itu otomatis kita sudah terdeteksi atau sudah masuk absen. Kita bisa cek di file Excel. Di sini saya sudah terdeteksi masuk absen sesuai dengan waktu absen saya. Nah, jika kita mengisi data kita namun dengan wajah orang lain, maka yang masuk absen itu terdeteksinya dengan nama tidak diketahui. Di sini saya contohkan dengan memasukkan data saya, namun saat absensi saya menggunakan wajah adik saya misalnya. Nah, di sini akan terdeteksi tidak diketahui dengan tingkat akurasi di bawah 50%. Dan juga di bagian Excel juga terdeteksi dengan nama tidak diketahui. Jadi kita harus mengisi sesuai dengan wajah kita, tidak bisa digantikan oleh orang lain. Mungkin itu saja yang dapat saya sampaikan. Apabila ada salah kata, mohon maaf. Wassalamualaikum warahmatullahi wabarakatuh.
Collaboration is key for team success. With ClickUp, you can easily manage your team's tasks and timeline.
TensorFlow, which is one of the most popular machine learning libraries out there, and this is going to allow us to do real-time face detection in the browser. And it's really easy to get set up with. The first thing that you need to do is download this library. There's going to be a link in the description below where you can download this library from. Also, you're going to need to download the models that you'll be using for your face detection. When we get to the model section, I'm going to list off all the models that we use so you can download them. Also, all the models are going to be available on my GitHub in the source code for this video, so you can get them there as well. To get started, we just want to create a blank HTML page here, and inside of this, we want to put a video element, because this is going to be where we render our webcam, where we do our real-time face detection. And this is just going to have an ID of video, so we can easily access it in the JavaScript. And we're just going to give it a width here. You can use whatever width and height that you want, but in our case, I'm going to use 720, and I'm going to use a height of 560. And you want to make sure you just set this to the autoplay flex, just to find for our video, because we haven't actually hooked up our webcam into our video yet. So let's go into our script here and work on doing that. First, we need to get that video element. So we're going to create an element here. We're going to say video is the key and an empty object as the parameter. Then we're going to have a method here, which is going to be stream. This is essentially what's coming from our webcam. Error, error just like that. And let's make sure it's an error log instead of a normal log. And now if we call that function, we can just say start video and go into our HTML, make sure to include that. So up here, we're going to include our script tag, make sure we set it to defer, and we want the source of that to be our script.js. Now, if we save that, you should see that it's going to access our video. It'll load up right here. And this is just a live preview of my webcam. It may be slightly delayed, but that's just because it's going through the browser as opposed to going directly into my recording software. So now once we have that done, let's also include our face API library while we're at it. So we can do a script here. We want to defer this one as well. And we want the face API. And we want to make sure that this is defined above our normal script so that it gets loaded before we actually run our script. And now we can work on actually setting up our script in order to detect my face as opposed to just render my video. In order to do that, we need to load all the different models. So let's do that at the very top. And this is all done asynchronously. So we want to use promise.all, which is going to run all these asynchronous calls in parallel, which will make it much quicker to execute. And in here, we just pass an array of all of our promises. And what you do is you want to call face API.net. And then this is going to be where you call all the different models you want. In our case, we're using the tiny face detector. This is just like any normal face detector, but it's going to be smaller and quicker, so it'll run in real time in the browser as opposed to being very slow. And we want to say load from, oops, if I spell it properly, load from URI. And in here, we have a models folder with all of our different models, so we're going to just pass that in. We'll just say /models. We want to do this a couple times for all of our different models, so let's copy that down 4 times. And we have our tiny face detector. The next one that we have is going to be our face landmark. Whoops, landmark 68 net. And this is going to be able to register the different parts of my face as opposed to my mouth, my eyes, my nose, etc. Next thing that we're going to have here is face recognition. If I can spell that, recognition net. And this is just going to be able to allow the API to recognize where my face is, the box around it. And then lastly, we're going to have is face expression net. And whoops, expression, just like that. And what this is going to allow it to do is to recognize when I'm smiling, frowning, happy, sad, etc. So what we want to do now is promise.all is going to take a.then. And after we're done with this, we want to call our start video. So we can remove this here. And now once we're done loading all of our models, it's going to start the video over here on the side. And it may take a little bit longer because loading these models does take a little bit of time, but it's fairly quick. Then we can actually set up an event listener. So we can say video.add event listener. And what we want to do is we want to add event listener for when the video starts playing. So then when the video starts playing, we're going to have our code down here, which we can say to recognize our face. For now, let's just do a simple console.log, and we just log whatever, come over here and inspect that. And as soon as the video starts, you see we get that log down here at the bottom, which means we know that everything's working so far. Now we can work on actually setting up the face detection. And this is actually incredibly straightforward to do. What we want to do is we want to do a set interval so that we can run the code inside of this multiple times in a row. We want to make sure it's an asynchronous function because this is going to be an asynchronous library. And all we need to do inside of here is the other detections. So we're going to just say detections is going to be equal to awaiting our face API. We'll just say face API dot detect all faces. And this is going to get all the faces inside of the webcam image every single time that this gets called. And we're going to do this, for example, every 100 milliseconds. And what we want to do inside of here is we want to pass the element, which in our case is the video element, as well as what type of library we're going to use to detect the faces. In our case, we're using the tiny face API. So we'll say face API dot tiny face, face detector options. And this is just going to be empty because we don't want to pass any custom options because the default is going to work perfectly fine for our scenario. Then we also say what we want to detect these faces with. So we're just going to say with face landmarks. And this is going to be for when we actually draw the face on the screen. We're going to be able to see these different sections. So the face landmarks is going to be the different dots that you'll see on my face, and then we can say dot with face expressions, and this is going to be able to determine whether I'm happy, sad, angry, upset, whatever, based on just the image that it gets of my face. So let's make sure I spell that properly. There we go. Now we can just log out these detections. So we're going to say, whoops, console.log detections, just so we can see that if this is working. And we can go inspect over here, and you can see that we're getting an error immediately, and it's saying tiny face detector options is not a constructor. And that's super easy to fix. This just needs to be a capital T over here. We can save this, and now we should be able to actually get our detection showing up over here. So let's make sure. There we go. And you can see we have a bunch of objects in here, and we just have one element in the array because there's only one face currently. And this is all the different detection information, expressions, etc. And what we want to do is actually display this on the screen. And to do that, we're going to be using a canvas element. So inside of our index.html here, we just want to style this canvas. It has to be positioned absolute so that it positions directly over top of our video element. And we don't actually need to put the canvas element inside of our HTML because we can do that in our JavaScript. So let's do that now. We can just say canvas is going to be equal to face API.create canvas from media. Oops, media. And we want to create it from our video element. Then what we want to do is just add that canvas to the screen. So we're going to say document.body.append, and this is just going to put this at the very end of our page. And since it's positioned absolutely, it doesn't really matter where it goes. And then what we want to do is get the display size of our current video. And this will be so that our canvas can be sized perfectly over our video. So this is just going to be an object with a width, which is just video.width. And it's going to have a height property, which is video.height. Now that we have that out of the way, we can actually work on displaying our elements inside the canvas. So we want to take our detections, which we have right here, create a new variable, which is going to be called resize detections. And we just want to set this to our face API.resize results. And we want to pass in here the detections that we have, as well as the display size. And this is just going to make it so that the boxes that show up around my face are properly sized for the video element that we're using over here, as well as for our canvas. Let's make this a little wider so it's easier to see. And now all we need to do is actually just draw this. We can say face API.draw detections. Whoops, detections. And what we do is we pass in the canvas we want to draw onto, as well as our resize detections. And make sure I spell face API correctly over here. Let's save that and see how this works. It's going to load in my face over here. And as you can see, it's already got a problem because our canvas isn't being cleared, and we have our video element being shown up over top, which is definitely not what we want. The first thing we can do to fix this is to actually clear our canvas before we draw it. So let's remove this console.log. And inside of here, right after we get our detections, right after we resize everything, and right before we draw, we want to take our canvas and we want to get the context, the 2D context. This is just a two-dimensional canvas. And we just want to clear it. So we'll say clear rect. And we want to clear it from 0, 0, and the width is going to be just the canvas.width and the canvas.height for the height. This is going to clear the entire canvas. Also, we want to make sure we match our canvas to this display size. So we can say face API.match dimensions. Oops, .match dimensions. and we put in our canvas, as well as our display size. Make sure we spell dimensions properly. And now if we save that, we should get much better detection over on the side. And if we just give it a second, you can see that it's detecting my face, and as I move, it's following me around. It also has a number, which is how % sure it is, so it's about 90% sure that this is the face, which is perfect. So now we can actually start drawing even more details. We can go into the face API.draw again, and this time we can draw landmarks. So we can say our face landmarks. This is going to take the canvas as well as the resized results. And if we save that, resized results, save that again, let it refresh over here, and now you'll see that it'll actually draw some lines and dots on my face based on where the landmarks on my face are. And you'll notice that's actually not working, and that's just because this should be called resized detections, not resized results. So let's save that, refresh it again, and let it do its work. And if we wait a second, you'll see that it now has all the different face detection. It knows where my eyes are, my eyebrows, my actual face shape, my mouth, nose, etc. And lastly, if we want to determine if I'm happy, sad, or whatnot based on this image, we can go to the face API here again, .draw, and this time we want to draw the face expressions. This is going to take a canvas element, as well as it's going to take our resized detections again. And now if we save that, it'll be able to determine my emotion based on just my image alone. So you can see that it's about 100% sure that I'm neutral, but if I make a surprise face, for example, it says it's 100% sure I'm surprised, and if I look angry, it'll say I'm angry, and so on, which is really impressive. And that's all it takes to create this simple face detection algorithm. If you want more artificial intelligence and face detection, let me know down in the comments below, and I'll definitely
I'm going to show you how to build your very own facial recognition ML script. First, I'm going to teach you a little bit about how this stuff works, and then we're going to dive right into the code. And you can follow along step by step. And by the end of this video, you will have your very own script that can identify any face within a photo. And it turns out it's actually super easy. I'm going to give you all the code for it also. And we're going to be following along through this tutorial provided by Ivan. And Ivan is also the sponsor of today's video, so thank you very much. And I'll talk a little bit more about what Ivan does as we actually use their service for free in this video. So Ivan put together this incredible blog post and tutorial about writing your own image recognition. And from the highest level, here's what we're going to be doing. We're going to have a starting picture like this. We're going to detect the faces from this starting picture. Then we're going to be calculating the embeddings on those faces. We're going to store those in PostgreSQL in a vector column. Then we're going to take another image of someone from that photo, but not the actual photo itself. We're going to calculate the embeddings of that new photo. Then we're going to use that to actually find this person's face within the original photo. And it's going to work really well. And so for those of you who are wondering what an embedding is, it is essentially a vector representation of text. And vector representations are really good at calculating the similarity of two things. So let's look at an example. So let's start with, we have a sentence, I love parks. And if you can imagine, for every one of these words, we're going to mark it as one or true. And then if we look at another sentence that is really similar, we can actually do that same calculation again. So let's look down here. The first one again, I love parks. And the second sentence we're going to be comparing it against is I love croissants. Now both have the word I, love, and now where they differ is parks and croissants. So parks, we have true for I love parks and false for I love croissants, and the inverse for croissants, false for I love parks and true for I love croissants. And this is the simplest way to explain how embeddings work. Now once we have these two vectors, the 1110 and 1101, we can compare those two vectors together to see how similar they are. Now they are similar because they both say I love, but they differ in what they love. So here it is. We calculate something called the distance. Now as we can see here, the distance between love croissants and love parks is represented with red right here. And the closer the entire sentence is, the more relevant they are to each other. So that's a very basic overview of how embeddings and similarity search works. Now there are much deeper dives on it on YouTube. I recommend if you want to learn more, please go find it. But what we're going to focus on today is actually writing code to do facial recognition. And it works the same way. Instead of sentences and text, we're taking images and we're converting the images into embeddings and seeing how similar those images are. So the first step we need to do is have a source image that we're going to retrieve all the faces for. Now here's a sample image. I'm going to be using a different one and I'll show you that in a minute. But what it is looking for are all the faces in this image. So it has 1, 2, and 3. Perfect. Now I created this Google Colab, which you can use. I'll drop the link to this in the description below. So we're going to need a few libraries to work with, and I'll tell you what they are as we go through them. And the first one we're going to need is this OpenCV-Python library, and that is an image recognition library. But we're going to install all three of these things. I'll explain what the other two libraries are later. So go ahead, click play, and then run. So next we're on step 1. We're going to recognize all the faces from our source image. And to do that, we're going to import this CV2 library, which is what we just installed. And then we have an algorithm. Now this algorithm right here is already written for us, and we actually have to download it and import it into Google Colab. And it just gives us the tool necessary to recognize faces from an image. So to download it, and again, I'll drop this in the description below, we're going to download this har cascade frontal face default.xml, and we just click this little download button right there. Next, we're going to come back to Colab and we're going to upload it to our Colab files. So you're simply going to take that downloaded XML file and drag it right into this window right there. Then you're going to right click on it and you're going to say copy path. And then where it says alg equals, you're going to replace this with the actual path of the file. There we go. Now it knows where to find it right here. Next, it's loading up the algorithm right there. We don't need to do anything. And then right here is where we have our source image. And for this one, I'm going to be using an image of the Always Sunny from Philadelphia cat, one of my favorite So I'm going to take that and I'm going to drag it over here as well. Okay, then we right click again, copy path, and we paste it in right there. All right, so now we have that source file. And again, what we're going to be doing right here is just extracting all the faces it can find. And in fact, let me show you that image real quick. So here we go. Here's the cast photo. Hopefully it grabs every single face from here. Sometimes it grabs most of them, not all of them, but even if it grabs most of them, that's okay. All right, next we're going to load up the image. That's what's happening here. And then we create black and white versions of the image because honestly, the color doesn't really matter when doing facial recognition. So that's what's happening here. And then here's where the magic is happening. We're actually detecting the faces from the image. Now there are a few settings here. Gray image is the actual image. Scale factor is the compression amount. and we don't need to mess with that at all. Min neighbors is how many neighboring faces to find when it does find one, and we're going to update this to be 5, and then the minimum size in pixels of a face, and we'll leave that as 100 by 100. Then it's going to detect all the faces, it's going to cycle through it, that's what we're seeing here, and then it's going to create a JPEG of each face, and that's it, it's ready to go. So let's see it work. So we click play. I missed one step. Before we do that, we actually have to create a folder called stored faces, just like it is right here. So let's copy that, and then we'll come over here, right click, new folder, stored faces, hit enter. Now we'll run it again and it should work, and it'll output the images to this stored faces folder. And there it is. Now let's take a look. Let's make sure it worked right. So we'll double click on it, and there it is. And again, and again, and again, and again. So it only grabbed 5 faces, so it's not perfect, but it's good enough. And if you adjust these settings here, you could get better results. But we don't need to for now. It'll be enough for me to show you how all this works. So now that we have each face extracted from that source file, what do we do with it? Now we need to convert those faces into embeddings. Now to do that, we actually need a vector database, and this is where Ivan comes in. We're gonna provision a vector database through Ivan. It's super simple. I'm gonna show it to you, and it is completely free. So sign up for Ivan, and Ivan is a platform that can host all of your data and really adds an incredibly simple abstraction layer on top of all of these other cloud database providers. And they're especially good at AI data. It's ivan.io, and once you do that, you're going to be greeted with this dashboard. Click on projects, and you're going to create a project. And let's do it. Faces, my organization, everything else looks good. I'm just going to say create project. Then you click create service. We're going to select the PostgreSQL service, and we're going to use the Google Cloud trial account. And it gives us a bunch of trial credits. So we'll just use those for now. And everything else can be the same. Then you just click create service. Now, this does take a little while, maybe 5 minutes, but we can track its progress pretty easily. Okay, so we have all this information. The thing that we're going to need most of all is this service URI, and we can just copy to clipboard just like that. And then we click next. We don't need that. We could just keep clicking skip, skip, and then finish setup. And if you look right here, it says rebuilding. I believe it says online when it's done, but it turns to green when it's done. I forget exactly what it says. And so again, this might take a little while. So what we're going to be doing when it's done, and we can get it ready now, is click this little quick connect button, and then we're going to copy this from the terminal, run the following code. We're going to click copy right there. And what we're doing is we're connecting to the database through PSQL through our terminal. Now, if we switch over to our terminal, here it is, and I try doing that right now, it's going to say could not translate hostname, and that's because it's not spun up yet. So again, it takes a little bit, but when it's ready, we will be able to connect, and then I'll show you the next step of actually creating the vector database. Okay, it's done. It says running right there. So now let's switch back to our terminal, and then we're going to paste in that command that we copied, PSQL, and then the Postgres endpoint that we copied. Hit enter. Once you do that, it should say default DB right there. Perfect. The first thing we need to do is create the extension vector. So let's do that. So here we go. Create extension vector : hit enter, and then that's it. Next, we need to create the table called pictures, and that's what we'll be doing here. So create table, and this is just SQL, create table pictures, and here are the columns it's going to have, including the embedding vector column. Hit enter, and now we're done. So now our database is all set up for us. I just switched back to Google Colab. Now what we're going to be doing is creating the embedding, so converting those images into vectors. So here we're going to import our libraries that we need to do those embeddings conversions, and here's the img beddings, which is what we installed earlier. Now right here, where we need to actually connect to our service URI. And to grab that, switch back to Ivan, and right here, service URI, we're just going to click the copy button right there, and then we paste it in. So then it's going to look for all of the files in stored faces. It's going to open each of those files. We're going to convert it into embeddings. And then right here, we're going to store those embeddings versions of the images in our vector database. And that should be it. We should be good to go. So let's do that. Click play. Okay, you could see all of the images are being converted. Perfect. And now they're stored in our database and it's done. That did not take long at all. Okay, now we need a new picture. So we have the source picture. We have all the faces from that source picture. Now we want to get a new picture of someone from that original photo and see if we can match it. Now to do that, I grabbed this photo of Charlie Day and we're going to upload that to Colab and then we're going to convert it. And then we're going to look for matches. So let's do that. So I'm just going to take it and I'm going to copy it over here by dragging and dropping. And we have charlie.jpg. I'm going to right click on it and say copy path. And then right here where it says file name, I'm going to highlight that and replace it with charlie.jpg. And here it loads the file. It gets it ready for converting, and then it converts it into an embedding. So let's do that. Okay, done. Now here's where the magic happens. What we're gonna do is we're gonna take that new photo and we're gonna look in our old photo for any faces that look like that new photo. And we're doing that through embeddings similarity search. And the line that really does all the magic is right here. So it says select all from pictures, and we're going to order by the embeddings similarity. So it's going to basically say, find all the pictures that we stored that are similar to the one that we're uploading right now. And then it's going to tell us which one it is. So we don't actually have to change anything. Let's run it. And there we go. It worked perfectly. So here's the image from the original source photo. Here's the image that we just compared it to. And yep, that is the same person. Different photos, but it did a similarity search and it found the right person. So that's it. Now you know how to do facial recognition yourself and write it from scratch. How incredible is that? And of course, you can extend this code and get so much more sophisticated with it. I want to hear what you're thinking about building with this. Let me know in the comments below. So thank you again to Ivan for sponsoring this video and making it so easy to provision a database for embeddings use. And I'm going to drop a referral link in the description below to Ivan where you can get an additional $100 of free credits on top of the $300 that they already give you. So I really recommend checking them out. Thanks, and if you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one. Coding assistants have changed the lives of developers around the world, but all of them require you to be connected to the internet and usually talk to ChatGPT. And that's a huge limitation, not only because of the cost, but also what if you're on a flight? What if you don't have internet connection? Now we have an incredible solution and we can have our own coding assistant completely locally. Today I'm going to show you how to use Cody, but we're going to be setting it up with a local model powered by Ollama, and it is open source. So many of you have asked for exactly this, the ability to have an auto-completing coding assistant that is run completely locally with a local model. Now I want to mention Cody is the sponsor of this video, so I'm going to show you how to set everything up, and you're going to be able to run your own autocomplete coding assistant completely locally. It is amazing. Let's get into it. The model we're going to be using today is CodeLlama, and we're going to be using the 7 billion parameter version, and it works really well. Now I have a MacBook Pro M2 Max, and it is instant. Now Cody comes in the form of an extension for VS Code. So if you don't already use VS Code, download it. That's what I use as my main coding editor. So go to code.visualstudio.com and download whatever version is right for your operating system. Once you do that, open up Visual Studio Code. You're going to come over here to the left side and click the extensions button. Then you're simply going to search for Cody, C-O-D-Y. Okay. Then you're going to look for Cody AI right here, and we're going to install pre-release, and it is done. So then we can close out of this window. Then over here on the left side, we have the Cody extension. So go ahead and click on that, and it's going to ask you to sign in. You can sign in with GitHub, but I'm going to choose Google. So I'll click right there. Then I click open. I'm going to sign in. Then I'm going to click continue. Then it's going to ask me one question, I believe. Sure, let's dive in. What do you use coding for? I'm using it for personal projects. And that's it. Then we authorize, and then we can open in Visual Studio Code. Okay, now we're signed in, and we're pretty much ready to go. So by default, it uses GPT-4 for everything, and it is completely free. So you get a coding assistant based on GPT-4 absolutely free. There are some rate limits for the free version, and the pro version is free right now. And I believe the next tier up is about $9 a month. But what we want to do is use autocomplete completely locally. So let's set that up. Open up your browser, and we're going to be using Ollama to power the inference. So go to ollama.ai, download Ollama and install it. Once you're done, you're going to open up Ollama, and you know it's open if you see the little llama in your task tray up in the taskbar. Next, we're going to open up a terminal in Visual Studio Code, and the model we're going to be using for inference is CodeLlama 7b. So what we need to do to download it is Ollama pull CodeLlama:7b-code and then hit enter. Now, I already have it, so it shouldn't download it again, but we'll see. Yep, so I already have it. It'll take just a few minutes to download. It's less than 4 gigabytes. And then we're ready to go. Next, we're gonna go over to the code Kodi settings right there, and we're gonna open Kodi extension settings. You're gonna scroll down and you're gonna look for this setting, autocomplete advanced provider. You're gonna click on that, and if it's not already selected, mine was, you're gonna click unstable Ollama. Now it is experimental and they do recommend using GPT-4, but this is definitely more fun. And right here you can select different models if you wanted to try this one, but this is supported by Fireworks as it says. And we're just gonna leave this as null because we're gonna do everything through Ollama. And then you can click out of the settings and we're pretty much done. Let's give it a try. Now, to prove that it's running completely locally, I'm gonna open up this output, and then over here, I'm gonna select Kodi by source graph. And here we can actually already see it. Kodi completion provider, unstable Ollama, CodeLlama. So let's give it a try. So first, I'm gonna just have it write me some code by starting with a comment. So I'm just gonna type Fibonacci method, then I'm gonna hit enter. And then it immediately, you can see how fast that was, starts giving me the code. So now I hit tab to complete. I'm going to hit enter again to go to the next line, and it completes the rest of it. Boom. Done. That's it. That is how easy it is, and it's super fast. Let's give it something a little bit more complex now. Now, if you did want it to autocomplete without starting to type, you can hit this little light bulb right there, and you could say ask to generate, and then you tell it what you want it to generate right there. So let's try that. Ask Kodi to generate. Write me code that outputs numbers 1 to 100. I'll hit enter. Kodi is working, and there it is. Very fast. And we can accept, we can retry, and we can undo, and also show the diff. So that is super handy. And I'll accept. There it is. And as I mentioned, Kodi is also really good at understanding the context of existing code. So if you remember in a previous tutorial, I wrote some code to detect faces in an image, and this is that code. So let's say I wanted to add some documentation right here. Add a new line, and then it immediately starts typing some comments for me based on the existing code. Draw a rectangle around the face. Perfect. Then if we just highlight this code, I can click here and say, ask Kodi to edit. And let's say instead of saving it as always sunny face 0, I'll say change the image name to asf_0.jpg. And I'll hit enter, and there we go. I'll accept. Perfect. And we can actually see all the output down here. And if we look right here, we could see provider model, CodeLlama 7b. So this is a small, high-performing model. Now, Kodi has a lot of other really cool features that you can use for free. They aren't currently powered by local models, but I want to show it to you anyways. So we can chat. We just click on that button right there. It opens up a chat. And here it's using Claude 2.0, but if we select this dropdown, we can use any of these other models, including one of my favorite, Mixtral 8x7b by Mixtral. These are all Pro models, but as I mentioned, Pro is currently free. So let's select Claude 2.0. So I'll say, what is this file about? Then I'll hit the @ sign and do find faces. Enter. And now it should tell me what's in that file. Yep. Python code detecting faces in an image and extracting them to save as a separate image file. We can also easily add documentation. So if we click right there, it's currently reading the code and adding documentation in real time. That's actually super cool how it does that.
and then we can hit accept right there. You can also edit code with instructions. So go ahead and click that and we can just say remove all comments, and perfect. It removed all the comments. Super fast too. We can also have it explain code, which I showed you, and we could also look for smells, code smells. So if you have pretty robust code and you're looking for any ways to dry that code up, this is a great way to do that. And then probably the thing that I would use most often if I was still building in production environments is generating unit tests. Very helpful, something I did not enjoy doing, although of course, very useful to have tests for your code. So there you go. Kodi is very powerful. I'd say better than GitHub Copilot because it has a lot more functionality baked in. Plus you can do autocomplete with local models. So check it out. Go to kodi.dev. Thank you to Kodi for sponsoring this video. And if you liked this video, please consider giving a like.